Thanks for having me. It's great to be here. I'd like to just start with an acknowledgement that this talk is largely based on a paper that my colleagues and I published a little over a year ago in Energy Research and Social Science with the same name. And those colleagues are Professor Tom Murphy in the physics department at UC San Diego, Dave Murphy from environmental studies at St. Lawrence, Tom Love from anthropology at Linfield University, and Melody LeHue from fashion studies at Kansas State. So it's a very eclectic group all over the country, all sorts of different disciplines coming together to work on this. And PLAN in the title is an acronym for the Planetary Limits Academic Network, which we launched shortly after the publication of this paper. So before we get into the meat of PLAN and modernity, I'd like to invite you all to join me in an intellectual stretching exercise to stretch your notions of space and time. So we're all used to thinking about things on this sort of spatial scale, right? And occasionally, if you go up in an airplane, you might look at things from this scale. But if you go into low Earth orbit, here's Lake Champlain from the space shuttle back in 1997, you get a very different sense of scale. And if you look at sort of an oblique view from the International Space Station, everything that we're used to thinking about is in fact very, very small. But this is just the beginning, right? You can go out to geosynchronous orbit and look at the entire planet at once. We've been to the moon, and this is the iconic Earthrise photo that really contextualized how small the Earth was. This is the moon, incidentally, is 200,000 miles away, just to kind of calibrate you on spatial scales. Here's a view of Earth from the Mars Reconnaissance Orbiter, 88 million miles away. Here's a view from Saturn, the Cassini Orbiter, in 2013, almost 1 billion miles away. And at this scale, Earth is just a little blue speck. And going even further out, Voyager took the farthest picture of the Earth from 3.7 billion miles away as part of its family portrait series. And there's the Earth right there, just one little blue pixel in Voyager's image. And as Carl Sagan said, you see a dot, that's here, that's home, that's us. On that dot, everyone you ever heard of, every human being who ever lived out their lives. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are all challenged by this point of pale light. So again, 3.7 billion miles away, Earth is just a single pixel. And in astronomers' units, that's 5.5 light hours. That's the distance that light can travel in 5.5 hours. Zooming out even further, this is the sun. This is an artist's rendition of the sun moving through the local interstellar medium, where the length scale is now 10 light years instead of 5 light hours. And of course, we're moving through a local interstellar medium in the backwaters of the Milky Way galaxy, which is 100,000 light years across. Our galaxy is just one in a local group of galaxies that is about 10 million light years across. And of course, we are just one of many groups of galaxies in the observable universe, which is about 100 billion light years in diameter. So we are very small, right? This place that we occupy is tiny and very unique. Now I'd like to try to help you stretch it in terms of time. So the universe was formed 13.8 billion years ago. And this is just a kind of scrolling timeline. Star formation started, the Milky Way formed 12.6 billion years ago. The universe started cooling down. The thin disk of the galaxy started 8 billion years ago. And when we get to the point of 5 or so billion years ago, the Earth started to form. So the Earth has only been here for a third of the life of the universe. Oceans formed shortly thereafter. We had this great bombardment. Life emerged on Earth. Cyanobacteria exercised the first global climate change experiment, converting CO2 to oxygen. Ozone layer formed. Multicellular life 2 billion years ago. And by 1.9 billion years ago, the atmospheric oxygen level got to 15%. Supercontinents formed and broke apart. More complex life started to emerge, eukaryotes. The Cambrian explosion tetrapods, the first tree-like plants. 300 million years ago, atmospheric oxygen peaked, and the Pangea continent, supercontinent formed. First mammals were on the scene 200 million years ago. First bees 100 million years ago. First modern birds 50 million years ago. First bovids 15 million years ago. And then 2.2 million years ago, the first members of the genus Homo arrived. So 2 million years out of the Earth's lifetime of 4.5 billion years, out of the universe's life of 13.8 billion years, humans in some form or another have been around. So here's a zoom in on the last million years, where Homo sapiens is rather late on the scene in the last 200,000 years. We've been through ice ages and interglacial periods, and in the last 10,000 years, things have really gotten very interesting. We developed agriculture and cities, and eventually industrialization. So I think it's helpful to compare the entirety of the 2 million years of human experience, by which I mean all Homo species, to that of a typical 75-year human lifespan. So for the first 70 years of our life, we have many different species of humans coexisting quite sustainably, I think you could argue. And then in the last 5 years, Homo sapiens came on the scene. 4 months ago, in the last 15 weeks, we developed agriculture. We picked up this new hobby, which gave us a lot of nice benefits. And then on Monday, started the Age of Enlightenment and science, where we really started thinking that we understand this place and that we can dominate our home. We discovered fossil fuels on Wednesday. So that's like, crack cocaine for the habit of agriculture and dominion. So this is starting a worrisome trajectory, right? If you were looking at the 75-year-old from outside, you start to worry. And then late last night, we really started trashing the place, the age of global rapid ecological devastation. So this stretching exercise is just to demonstrate that modernity is not normal. Everything that we take for granted, things we've lived with our entire lives, industrial agriculture, built up cities, advanced chemical and petrochemical industry, air transport, all of this is very unusual in the universe. All of this is very new. This is a very recent habit. It's almost as if we are a firefly that was born into a fireworks show and thinks that this is what life is like at the grand finale. So there's no guarantee that everything that we take for granted is sustainable or lastable. And of course, all of modernity has been fueled by fossil fuels, coal, oil, and natural gas, which we've been burning at an ever accelerating rate. And of course, most people are really concerned about climate change. I am too. But the fact that the CO2 is building up in the atmosphere is only one of the problems with modernity. But this cannot continue. Setting even aside climate change, there are limits to energy supply. The past century has been well fit by about 2.3% per year annual growth rate in energy consumption. That's a factor of 10 every century. So what would that look like if we go out a couple more centuries at this growth rate? In 400 years, we would need all of the sunlight striking Earth to fuel modernity, every single photon with nothing left for photosynthesis or the environment. In 1400 years, we need the entire energy output of the sun. And in 2500 years, we need the entire output of all the stars in the Milky Way galaxy. So this is obviously not a prediction. This is just a statement of the absurdity of continued exponential growth. But even if you imagine that there's some amazing new breakthrough technology in physics, some new physics that we haven't discovered yet that would give us all of this endless energy, we'd run into problems with the thermodynamic waste heat from the energy consumption. In just 100 years, the waste heat from this ever exponentially increasing energy consumption would have as much influence on the temperature of the Earth as today's anthropogenic climate change. In 200 years, it would be 10 times bigger than today's climate change. And in 400 years, the Earth's temperature would reach 100 degrees Celsius, the boiling point of water. So no technology is going to save us. No new energy source is going to allow us to continue this exponential growth for hundreds of years. Energy is not the only thing that has been growing exponentially or quasi-exponentially. Here's a series of graphs from my colleague Tom Murphy's blog, Do the Math, which he called Death by Hockey Sticks. The human population, global energy usage, global per capita energy usage, gross world product, the size of the economy, gross world product per capita, annual copper production growing like a hockey stick, annual CO2 emissions, annual plastic discarded, and perhaps most tragically, extinction rates for birds, mammals, and amphibians. Everything growing exponentially. Growth is just such a big part of what we're used to. Everybody wants growth. Everyone thinks growth is normal and desirable. Even the so-called sustainable development goals call for quote unquote sustained economic growth, which is completely impossible and unsustainable. We are so dependent on growth. When there is not growth, we call it a recession or a depression. Our economic system cannot tolerate the lack of growth, but yet the planet cannot tolerate continued growth. It's no surprise, people are trying to come up with ways of separating the economy from the physical world. Well, perhaps we could just decouple the economy from its physical impact. So this is from a paper of Tom's in Nature Physics last year, imagining that the economy just continues to grow a factor of 10 every century. That's that same 2.3% per year. And people argue, well, the physical impact might saturate at some level, while the economy could keep growing. What does that mean? That means that physical goods have an ever decreasing share of the economy. That means the smaller fraction of everyone's pay is going to go to physical things over time. That means that physical things would become arbitrarily inexpensive. And that's just impossible for finite, limited, essential commodities. So as Tom argues, economic growth is really a self-terminating thing on a finite planet. There are limits to growth, as we were warned 51 years ago. So if we're not going to grow, if we can't continue growing forever, and I'm not saying growth's going to stop tomorrow, but at some point growth will have to stop, what happens next? So ecologists would tell you that if you are a species that is living on renewable resources, you might have exponential growth at the beginning, but eventually that'll flatten off into a logistic curve approaching the so-called carrying capacity of that species. But our species is not one that is living on renewable regenerating resources. We're living on fossil fuels. My colleague Ekman Afzal put together this graph of the ecological footprint of humanity as a function of time. And so we had many, many, many years, millennia of sustainable life. And then again, about a few weeks ago, we discovered the age of exuberance, fossil fuels, modernity. And that took us right up to the biocapacity of the planet. But we of course did not stop there. We continued into what William Catton calls overshoot. By overshooting the biocapacity, we're actually degrading the biocapacity of our planet so that the sustainable ecological footprint of humanity is actually going down with time, and while we are continuing to shoot upwards. So you can tell what's going to happen, that sooner or later some kind of a simplification or a collapse is inevitable. And we're sitting right there in the overshoot, some distance away, who knows exactly how far from a collapse. So I'd like to share some thoughts from our paper now. We really suggest that continued fixation on growth is not a good thing. It threatens to drown out responsible action. Growth needs to be recognized as a beloved enemy. We can never hate it for all that it has provided us in the past, but neither can we afford to carry it into the future. Continuing to promote growth as a goal, even if for noble reasons of equity in the developing world, risks overshooting Earth's steady state means and making the world ultimately worse for all. As noble as it may be to wish a modern living standard for an eventual 10 billion or more people, it's likely that committing to such a course would result in more human suffering than would transpire under the adoption of more modest goals. The responsible path, we argue, is to reduce global resource dependencies and abandon the imperative for growth starting now. We suggest that modern industrial humanity is effectively hurtling forward in a giant unauthorized experiment, lacking a coherent design or strategy, which has worked well enough on a non-human dominated planet. At present, democracies, markets, and a handful of authoritarian regimes are making the rules, largely uncoordinated rules, sometimes incompatible rules, and absent explicit reference to principles commensurate with a finite planet. Our past success leading to this moment does not portend a similar future due to the explosion of people and resource use that's been unleashed in a very short amount of time. And one does not have to look far to see seemingly intractable global scale predicaments that interconnect and appear to be growing more severe. These times, this modernity, these are unprecedented, abnormal times. And subsystemic, if not systemic breakdown can only be avoided if its prospect is taken seriously. Just to elaborate on that, if we don't take seriously the possibility that we could be moving into a collapse, if we just keep going, pushing economic growth, pedal to the metal, nothing would better guarantee a systemic collapse. So we really have to take this seriously. We acknowledge that confronting these challenges will require substantial departures from the workings of current institutions and cultural systems in order to forge a path compatible with planetary limits. Political and economic systems will need to address the fundamental drivers for growth, productivity, and resource exploitation in modern society, and incorporate more systematically the important roles of ecological services and community. Entrenched institutions will resist big changes, and leaders of those institutions will argue that departures from the present trajectory threaten prosperity and threaten happiness. But holding on too long to the current path will translate to maximal suffering by overextending humanity's claim on nature and plunging future generations into intractable decline or collapse, left with a depleted resource base. We have to think about ethical issues which accumulate rapidly here and lead to questions of meaning and existence that humans have long pondered, though now made critically important by the dilemmas outlined here. What ultimately matters? Is it economic growth that ultimately matters? What can we as academics do in the face of these challenges? We argue that at stake is nothing less than the preservation of the sum of human academic accomplishment for posterity. You can imagine if things go really badly, all of the knowledge of the Enlightenment might get lost for posterity. Now, the current structure of academia, which arose in the 19th century from a reductionist approach to knowledge creation, is not really well suited to fostering an integrative understanding of the challenges now facing humanity, much less to developing a framework for a future that is compatible with planetary limits. Divisions of academics into colleges and departments and disciplines and sub-disciplines facilitate deep research in relatively narrow areas. Our disciplines are split into different categories like the arts and humanities and social sciences, physical sciences, engineering, life sciences. Each of those consists of many different disciplines. Each of these disciplines consists of many sub-disciplines. And so the academy is essentially balkanized into tiny little silos where each of us is studying increasingly narrow problems that make it challenging to integrate all of that knowledge into an understanding of how to move forward. And even our professional societies are generally organized around specific disciplines. I'm a member of the American Chemical Society, that's for chemists. There's the Ecological Society of America for ecologists. Sometimes there's intersections between two disciplines, but these societies are largely populated by scholars with similar training, for example, similar terminal degrees in a particular field. So that was the motivation for forming the Planetary Limits Academic Network. This is a new community of scholars who appreciate the complex nature of planetary limits and are open to collaboration on actionable research addressing the existential predicament our civilization faces. This is an intrinsically transdisciplinary network welcoming scholars from all disciplines. And the goals are to identify scholars who already understand humanity's interlocking issues, to shepherd an intellectual transition from awareness of these issues to systems-level thinking about them, to catalyze new collaborations among scholars from different disciplines, like, for example, physics and fashion studies, to develop an integrative understanding of planetary limits and appropriate responses, which might include, for example, envisioning and laying the groundwork for realistic scenarios of the future, not techno-utopian scenarios, not apocalyptic scenarios, but a more likely reasonable middle ground for the future. To kick off this network, we developed a set of 10 foundational principles, which, if you like, is the intellectual foundation on which we want to lay the bricks that will form the edifice of our understanding and approach to planetary limits. So I'll just briefly walk through those principles. Number one, humans are a part of nature, not apart from nature. It's a really critical way of thinking about the world that most of humanity does not engage in. Number two, non-renewable materials cannot be harvested indefinitely on a finite planet. That sounds obvious, but it is obvious, right? But we just don't think about that all the time. The ability of Earth's ecosystems to assimilate pollution without consequences is finite, and I would argue that we have perhaps already surpassed that. Number four, energy throughput is essential to all human activities, including the economy. We can't get away from energy as a central driver of our activity. Number five, technology is a tool for deploying, not creating energy. People often say, oh, well, technology will change things, or they'll think of something. But all technology allows you to do is harness energy in different ways, do different things with energy, but doesn't create energy. Number six, fossil fuel combustion is the primary cause of ongoing global climate change. I think that's pretty obvious. Not the only cause, of course, deforestation and so forth, also very important. Number seven, exponential growth, whether of physical or economic form, must eventually cease. We don't take a position on when it must cease, but it cannot continue indefinitely. Number eight, today's choices can simultaneously create problems for and deprive resources from future generations. So we have to think about the ethics of what we're doing today. Number nine, human behavior is consciously and unconsciously shaped by mental models of culture that, while they are mutable, impose barriers to change. It's not so easy for someone to just go and become sustainable because we're embedded in this culture and these systems that impose barriers to change. And finally, apparent success for a few generations during a massive drawdown of finite resources says little about chances for long-term success. We can't simply assume that the way things have been going or the way things will be going, or investment advisors might tell you that past performance is no guarantee of future returns. Now, we recognize that many individual scholars are already working on relevant pieces of this puzzle, notably ecological and biophysical economists and degrowth scholars. So we're not presuming some whole cloth invention of new fields and new research. Instead, we hope to see a disparate set of scholars from fields that do not currently have significant engagement with these topics unite under a common umbrella, sharing similar overarching concerns and approach, while also attracting professional migration into this existentially important space. The scale of the problem is massive, touches on all corners of humanity. So a credible effort needs historians, anthropologists, scientists, engineers, psychologists, economists, experts in business, trade, and communications, artists, theologians, in every academic field to harness the knowledge and wisdom of all humanity. So we launched PLAN in late 2021. We're currently almost to 100 members across 16 countries. Zooming into the US, we have 66 US members. There are 3 of us in Vermont right now, all of whom are in this room. But we hail from 26 different states across the country. And here's a breakdown of people's self-identified primary discipline type. So intriguingly, we have a plurality of social and behavioral scientists, not physical scientists. I'm a physical scientist by training. I think it's lovely that this is not dominated by physical scientists, because physical scientists and to a lesser extent engineers are a big part of what got us here. But we also have substantial components from the arts and humanities, and life and health sciences, and professional disciplines as well. We have organized ourselves using an approach called sociocracy, which I'm happy to talk about in more detail if anyone has questions about that. But it's a dynamic governance approach that really engages as many members as are interested in pushing the network forward. We've launched a monthly virtual seminar series, which allows folks from all over the world to come together to hear from a PLAN member about a particular topic. And then we follow those up with monthly discussion sessions on a platform called GatherTown, where people can kind of mingle around and have informal conversations. We're working on a book proposal for an edited volume on the topic of planetary limits. We've developed an online resource library where members can point out resources, whether they're books or articles or cartoons or what have you, that touch on planetary limits. And we have a very interesting member discussion forum on our website that we've recently launched. So our hope with this network is that we might spark debate and deep thinking about how human civilization might thrive for millennia to come, rather than simply survive the bottlenecks of the last few decades. Humans have been around for 2 million years. Modernity has been here for, depending on how you count, a couple hundred years, right? So let's try to think about more than next week in a human life, in that analogy. Let's think about what the next couple of months are going to look like. Any scholar finding resonance in this message might ask what role their current research plays in addressing these issues. For many of us, this has been a really tough question to ask. I gave up my entire research program at the intersection of chemistry and astronomy because it had nothing to do with any of these issues. And while it was very interesting, it just seems completely trivial in the context of these existential issues. Ultimately, what is important? What elements of your work can contribute to a better future? So in this paper, we encourage bold migration into this intellectual space in order to achieve critical mass in understanding how human activity might fit within planetary limits. And we welcome all interested scholars to join the Planetary Limits Academic Network. And you can look us up at planetarylimits.net. Thank you very much.